Folks, I want to just give you a little bit of the motor project on Uncle Dorkel. I was going to combine this video in with some other videos of Uncle Dorkel as I go along, but it's raining today, so I have to really take a day off from it anyways, because as I told you before and you're well aware of, I have to work outside on the bench. So what I am going to do here is to just show you what I've done so far and how it's working. Well, here we are, Halloween Day, and it's kind of cold out here today, but I want to show you what I did. I got the motor mounted. I'm going to show you that in a minute here. And I also made a little battery tray. I changed around where the battery is located. Okay, here's what I did. I got the tubing up in here, clamped to the 4 nuts that I showed you on the 1/4-20 thread bolt. Comes down here, and I've got a little piece of dowel, and I had to build it up with tape and stuck it inside this hose here, and drilled a hole and put a nail through it, cut the point off, and just wrap some tape around it. So this gives a little flexibility, not much, it's just a little bit. And originally the battery was back here. There was no way I could mount the motor without these motor flanges getting in the way of the battery compartment here. So what I did is simply removed the battery and decided not to put it here, and put a piece of plywood here, centered this, and put 3 screws in here, and screwed this whole thing down, and then made a battery tray here. And I'm not done with this yet. I want to put a little felt in here, and the battery will go in like this, okay? And it can go all the way back here if necessary. The metal I had, I didn't have it a piece long enough, but not a problem. I can put a little foam rubber in there. The battery can sit back here, and I'll be able to get it out, because before I was struggling to get the battery down inside here. The D.I.Y battery will still be over here. That hasn't been touched. And with this arrangement, I'll be able to replace the fuses. All I got to do is remove this battery, you know, and I got this galvanized piece of sheet metal here, which I smoothed off the edges on. And I'll be able to get at the fuses. Of course, these fuses are going to have to be upgraded to heavier fuses, and I might even rewire this. I don't know yet, as I don't think these wires are heavy enough. But anyways, so the next step is to get these wires onto the terminal strips that Steve sent me. And the relay assembly will probably sit in here. The relays and the terminal strips will sit in here. I want this to be removable. So what I did is I screwed this plywood down through these thin pieces of plywood and down to the heavy plywood base down below with 2.5-inch screws. I had to use sheetrock screws in here. I didn't have any spacers, so I kind of leveled it off as much as I could, and I had to use a 2.5-inch screw in order to reach the base plate in this one. And this was real hard to get a screwdriver in there. I couldn't use power tools in here, had to screw it down by hand. So she's good and strong. And there's a lot more to this, so this particular section of the video will be added to the rest of the video on the construction of this, or revamping, or whatever you want to call it. And all these wires will be redone. But I'm not going to go into a lot of detail as to how I'm wiring it. I'm going to do it and then show you afterwards. But I will show you the motor now, and you'll see how it goes. I'm going to have Tommy hold the camera while I energize the motor on both the 12-volt and the 6-volt battery. First of all, I'm going to touch these wires on the 12-volt battery real quick to give you an idea of how fast the head turns. This is 12 volts now. I'm going to just touch it quick because I don't want it to spin around all the way. Okay. Now I'm going to reverse it. I'm just reversing the polarity right now. Okay. And I can go a little more. I'm watching that I motor wire. Now I'll bring the head back forward. Oh, too much. It's a little too fast. Okay, now we're going to use the 6-volt battery. You just stay on the recording.
Turns fast now. It turns good.
Turns good, but too fast. Too fast. It could get out of control if I'm not paying attention. All right, here we go. This is with 6 volts now. That's a lot better. It's manageable. But you got to remember, this is only a 4 amp hour battery. It's not going to last very long at all. There's a little drag there. That's why it was going real slow and then it speeded up. There's a binding action because this thing is off center.
I kind of like the other one better. It turns faster.
I don't want it too fast. Okay. Okay, now if you look at the stick, you're going to see the stick move like this. And this is why I wanted to use a flexible hose in there. And that's why it's binding. See how the stick is like that? Because that's just the way the Mickey Mouse arrangement that I put up underneath there. So I don't know how much current this thing is drawing under load like this. And being that it's only 6 volts, it's probably drawing a heck of a lot of current. We'll put it back. But it's manageable. See, when it gets to the right turn, it kind of chugs along. But I'm worried, if you look down here, I'm worried about the sloppiness and the angle could pull this coupling loose from the gear and could go like this and eventually go on a little angle and literally strip out the plastic. What I might do is I might make a little piece of little thing here out of galvanized sheet metal. It'll come down and over like that, so it captures the top of the plastic, but not the hose. And the hose can ride through, and the plastic will be underneath the galvanized sheet metal, so that it won't have it'll have the tendency to be held down here. Right now it's not loose, but it could be. Now let's get this head turned around here. Okay, 6 volts is a nice good speed that I can manage with. But we can get this down to 6 volts with resistors anyway, so we're not worried about that. The biggest issue was the mechanics of this thing. The electrical I can work with, and we're getting there. So stay tuned for more. Okay, well, there's going to be more as weather permits. It's supposed to be fairly mild for this time of the year, starting tomorrow. So it's raining today, so as I said, and I can't do anything anyways on the project. So the next step in the project will be getting the board made up with the relays. And what I'm going to do is to have a piece of plywood and probably use a piece like this here. This is happens to be 3/8. And I want to mount the relays on here and wire them up and then put the whole thing in there and then just screw it down, because trying to wire inside the dummy is too difficult. So I'll do all my electrical connections here with the relays. There's going to be 2 relays used, one for the left direction, and then with the double pole, double throw, center off switch. It doesn't have to be a double pole, double throw in this particular circuit, but my original design without the relays would have had to been a double pole, double throw switch. But the point is, one relay will be energized when it turns left. Then when it goes right, it'll be de-energized and the switch goes over to the other side and that will be energized, and the head will be able to turn the opposite way. So there'll be 2 relays on this board. If this board isn't big enough, I got a little bigger one I can probably come up with. But I only got so much space between the motor and the side of the Dorkel. So there's only so much room there that I can get things in. But these relays are relatively small, so I can get the head motor, which, like I say, would be 2 separate relays, and I may or may not use a relay for the mount trigger. The mount trigger switch will handle 10 amps. The mount trigger is roughly full energized, is about 5 amps or a little less. And the wire in the remote control 12 conductor wire cable is at least 20 gauge and most likely 18. And I can always double up the conductors. Now, what I'm going to do, it's a 12 conductor cable, and what I'm going to do is there's a shield in there, or there's a bare wire. I don't know if it's actually a shield or not, but there's a bare wire running in there. That's going to be a common negative. Then I'm going to take another one of the black wires. There's only black and white wires there, and I'm going to combine them so that that's going to be the common negative. So you're going to have doubling up. And then if I need a double up on the 12 volt supplying coming up to the remote control, I can always double up to white wires. That's not a problem, but most of your heavy current draw is going to be done after the relays. In other words, from the relay point on, and the only control that's going to need energizing will be the relay coils themselves, which draw very little current. They're 12 volt coils. So if I use a 6 volt battery for the head motor, that's on the relay circuit. Okay, the coil that operates the relay has to have 12 volts in order to energize. Also, I have to use the 12 volt battery for the mount trigger because that's designed to run on 12 volts. Try to run that on 6 and it'll just barely move. So there's still going to be 2 batteries in Uncle Dorkel unless I can put a resistor and slow the motor down that way. But using a resistor, you waste a lot of energy, and it's an inefficient way to do something. But these are all experimental anyways, and we're not anywhere near that stage yet. But we're getting there. And I got a lot of stuff I got to do. I'm going to probably take out a lot of the wiring that's in there that you've seen and redo it all. Not all of it, but some of it, like the original mount trigger wires and stuff, and the head wires, it's all on one side. We're going to be redoing all that and probably laying it around the back and out of the way so I can get at it if I need to. Well, anyways, there'll be more videos coming up on this. I want to thank you for watching, and I appreciate all the support from all my good viewers out there that are with me on this project, and those of you also that enjoy the comedy videos that I put up. And I want to thank you once again. If it wasn't for people like, I can name a whole bunch of people that's really helped me out, just to name a few, Steve and Joe and Marianne, and Cool Blue Lights, and UMA Junk Collector Don, and so many others that have helped me out on this, and I just don't know what to say. I appreciate it more than you'll ever know. Thank you for watching, and stay tuned because there'll be more coming to a computer near you.
Bye.